So in this video, we focus on finding the gradient of the curve at a given point. So how can we find the gradient of the curve at a given point? So let's say we have, this is the function that we have, which is y equal to 2x. So remember, as we are differentiating this function, we are obtaining the gradient function, right? Now, let's say when we differentiate this function, we're going to say, okay, dy dx will be equal to, when you differentiate this, you know, this is the power 1. You drop the power 1 times 2x, 1 minus 1. Then this will give us 2x to the power 0. This will give us a 2. Remember, this is the gradient in this case. Yeah, so this is the gradient. Now, let's say this same function now, it is 2x. Now it has the power 2, basically. So how can we find the gradient of this function now? Let's say at the point x, which is equal to 1. So what we're going to do is we're going to say dy dx will be equal to, drop the power 2 times this, it will be 4x. 2 minus 1, it will just be equal to 1. So remember, this is the gradient function now. Now what is the gradient now of this function at the point when x is equal to 1? So we're going to say when x is equal to 1, then we're going to say dy dx will be equal to 4. We substitute with the 1, then we're getting what? The 4 as our answer, basically. So this is the gradient. Remember, this is not the gradient. This is the gradient function. So the gradient is this one when you substitute with x, the given value of x, in this case it is x equal to 1, basically. So the second question is y, which is equal to x squared plus 7x minus 2. Then we have 2, 16. So this is the curve that we have. So how can we find the gradient of this curve when x is 2 and y is 16? So I'm going to differentiate this function so that we obtain the gradient function. So we're going to say dy dx will be equal to, when you differentiate this will be 2x plus 7. This is the gradient function. Now what is the gradient? This point, remember we have x, so we are substituting with x, which is equal to 2. Basically, we're just using a 2. This is the value of y. So our main focus is this value of x, which is a 2. So we're going to say dy dx will be equal to 2. You substitute with a 2 plus 7. Then this will be 4 plus 7. Then this will give us 11. So the gradient of this function at 2, 6, it is 11. So that's how we can find the gradient. Then next question is we have third question, which is y is equal to we have 2x squared. This is 2x squared minus 3x plus 7 and x equal to negative 2. So this is the curve that we have. So how can we find the gradient of this curve when x is equal to negative 2? So what you do is first you need to obtain the gradient function of this curve that we have. So we are going to say dy dx will be equal to, this will be 4x minus 3. Then when x is equal to negative 2. So we're going to substitute where there is x with the negative 2. So we're going to say 4. This will be negative 2 minus 3. Then this will be negative 8 minus 3. Then our gradient will be negative 11. This is our gradient. So that's how we can find the gradient of this function. Then the fourth question, let's try out this one. So how can we find the gradient of which is y, which is equal to, we have x to the power 3. Then we have minus 4 over x. Now at x equal to 1. So how can we find the gradient of this function? So first we need to differentiate this function. But as you can see here, we can change this one so that it has the power, which is the power negative, then below as you're differentiating the power, dropping the power, then we're saying the power minus 1. So we're going to say y is the same as x to the power 3 minus, this would be 4. Then as you can see, this one, we're going to say times 1 over x, which is the same as x to the power 3 minus, this will be 4. Then this will be x to the power negative 1. So y is x to the power 3 minus 4, then x to the power negative 1. So we're going to say, we differentiate this function. So you drop the power 3, then x to the power minus 1, which is 2, minus, and then you drop the power, which is negative 2. So this is negative, as you can see, when you drop negative 2, it will be positive. So 2 times 4, this will be 8. X, then you say negative 2 minus 1, this will be negative 3, right? So this will be 3x squared plus 8 over, we are changing this one so that it has the positive power. So this will be x to the power 3. So what is the gradient now? This is the gradient function. So what is the gradient? When x is equal to 1, so this will give us 3, open, you put a 1, plus this will be 8 over, this is a 1 to the power 3, then this will be 3, 1 to the power 2, that's a 1, plus this will be 8, 1 to the power 3, that's a 1, so this will give us 3 plus 8, so therefore the gradient, which is dy dx, will be equal to 11. So that's how you can find the gradient of this function. Then let's look at question number 5, which is our last question. So let's say we have the curve, which is 3x to the power 3 minus 2x squared plus 1. Then at x equal to negative 2. So how can we find the gradient of this curve when x is equal to negative 2? So for us to find the gradient, we're going to say we differentiate this function. So we're going to say dy dx will be, drop 3 times 3, then x, 3 minus 1 minus, you drop 2 times 2x, 2 minus 1 plus the derivative of a constant number, that's a 0. Then this will give us 3 times 3, that's a 9. Then we have x squared minus, this will be 4x. Then 2 minus 1, that's a 1. Then now this is dy dx, which is 9x squared minus 4x. Now when x is equal to negative 2, meaning that what is x, we're going to substitute with the negative 2. Remember, this is the gradient function. So the gradient, which is dy dx, will be 9. We're going to put a negative 2 squared minus 4. We put a negative 2. Then this will give us 9. Open. This will be positive 4. Then this will be plus 8. This will be 6 plus 8. Then this will give us 44. So this is our gradient. So basically that's how you can find the gradient. If you're given a curve at a certain point, that's what you do. You differentiate that curve, then while there is x, you're going to substitute with a given point, which is the same as when you have, let's say, 2, 1. So your main focus will just be on this value of x and not this value of y. Remember, the curve, it has, this is what it has, right? So meaning that as you are differentiating, the gradient function will have x. So when you substituting, you're going to use this value of x, not the value of y. So this is what I wanted to show you. Thank you so much for your time.